Okay, so this is a continuation of question number 8 from page 46 of the Calculus and Vectors Nelson textbook. Today I'm going to finish this off by doing parts C and E. And this is from the 1.5 Evaluating Limits chapter where you're asked to use the change of variable method. So for part C, this is the limit as x approaches 1 of x to the 1/6 minus 1 all over x minus 1. Right now the issue is if we plug in x equals 1 into this entire function, we're going to get 1 minus 1, which is equal to 0 in the denominator, and we cannot divide by 0. We can go ahead and make some let statements for the change of variable method. We can say let u equal x to the 1/6, and why x to the 1/6? And so I can easily change this to x. I can do that by raising it to the power of 6, which will be u to the power of 6 is equal to x to the 1/6 all to the 6th power. This gives me x to the 6 over 6, which can be simplified to x. We now want everything in terms of u, so all I have to do is plug in x equals 1 into x to the 1/6. This gives me u equals 1, therefore u is going to approach 1. I can now rewrite this limit as the limit as u approaches 1 of u minus 1 over u6 minus 1. I can then rewrite this as the limit as u approaches 1 of u minus 1 over u cubed plus 1 multiplied by u cubed minus 1, because this is a difference of squares. Now remembering our same opposite, always positive acronym, we see we have u minus 1 at the top, and we can simply factor out u cubed minus 1 to allow us to cancel the u minus 1s. We can rewrite this as the limit as u approaches 1 of u minus 1 over u cubed plus 1 multiplied by u minus 1 multiplied by u squared plus u plus 1, recalling the SOAP formula. I now notice that the u minus 1 simply cancel out, leaving me with the limit as u approaches 1 of 1 over u cubed plus 1 multiplied by u squared plus u plus 1. I can now get rid of my limit notation and simply plug in u equals 1 everywhere I see a u. This gives me an answer of 1 over 6. Moving on to part E, this is the limit as x approaches 4 of the square root of x minus 2 all over the square root of x cubed minus 8. Now although the question says to use the change of variable method, we don't really need to do that, and here's why. I can simply go ahead and rewrite this limit as the limit as x approaches 4 of the square root of x minus 2 all over the square root of x all to the power of 3 minus 2 cubed. I can then rewrite this as the limit as x approaches 4 of the square root of x minus 2, and then recalling our difference of cubes formula using the SOAP acronym, same opposite always positive, the first bracket will be the first term minus the second term, and the second bracket will be the first term squared plus the second term multiplied by the first term plus the second term squared. I now notice that the root x minus 2 simply cancel out, leaving me with the limit as x approaches 4 of 1 over x plus 2 root x plus 4. I can now get rid of my limit notation and plug in an x equals 4 everywhere I see an x. This gives me an answer of 1 over 12.